Good morning, everyone. Welcome to another episode of XR Talk Show. Today is July 10th, 2019, 3 o'clock p.m. California time. And today we are going to do a golang, a live golang programming. And we are going to write a small script that process thousands, 5,000 of files, 10,000 of files to generate a list of links, basically. So in this, you will learn, if you are new to this, is kind of for beginners, and you will learn, if you don't know Golang, you will learn some Golang, and hopefully, you'll learn something about Golang or inspire you to learn the Golang language. Now, of the programming languages, I love Golang because of the industrial languages. Among Perl, Python, Ruby, Java, JavaScript, for example, including Clojure. For example, all these languages, Golang is my favorite. So these are industrial languages. My favorite language is of them all is actually Mathematica, but that is a math language or science-oriented math language. Anyway, so in industrial languages, my favorite is Golang because Golang is actually the most simple to learn. The concept of Golang, the programming language model is very simple. It's simpler than Python, Perl, Ruby, JavaScript. Okay, and it is fast. Let's see, Xali Golang. It's fast. It's almost as fast as C. Uh, so I have a tutorial about Golang. You can, if you like to study Golang, read from my tutorial. So it's simple. The language is very simple and it's super fast. It's as fast as you can get. It's similar to C, the speed of Golang. And it can be compiled or it can be run as a script, just like Python or Perl. Like you don't have to go through the write code, compile, then run the code. This loop, you just write it and run it. You can if you want, just like Python, Ruby. But if you want, you can also compile it. So you got a binary and send it to a friend, and your friend can run the program. So it becomes an independent application. Your friend does not need to install the Golang language, which is the case for if it is Python or Ruby. So this is a great advantage. You can just compile the code and you run anywhere. It actually does. So it's the language is very simple and it's very faster, like 6 times in general, 6 times faster than Ruby, Python, Perl. And it can be compiled or run as a scripting language. And the documentation of Golang is superb. It's the best documentation ever. I read tens of documentations in the past 30 years. The Golang is one of the tops. The great documentation is rare actually among all programming languages and technology. Programming language spec or programming language documentation or the documentation for an application for such as Apache, Unix, Unix man pages, and many documentations. So Golang documentation is the best. Most the documentations in the programming industry is crap. It's like below the standard even. But Golang is truly great. So simple language, very fast. You use it as a script, or it can be compiled. You can use it as a system language. It's designed to be a system language, like C or C++. And then the documentation is superb, and it supports functional programming. I am always I have always been a functional programmer for the it's beginning in the 1990s with Mathematica. I do not like object-oriented programming at all. In my own programming, I never do use the object-oriented model. I always just do functional programming style. You just write functions, no objects, no this inheritance crap. Okay, so Golang supports functional programming well. Golang is not extreme like Haskell, where you have then you have like monads. Okay, you have currying, you have all those less practical things. But Golang supports functional programming because very well because a function can return a function. Function uh, is a uh, is a expression by itself. Function can return a function, and function can take a function as argument. So in that respect, it really is what you need. So Golang. So let's start coding Golang. Okay, so let's begin. So let's see how many people are watching. 2 or 3 people. So if you like, well, I mean, okay. So you are here, and hold on a second. So let's say hi or something. Oh, hey, good morning. Break the loop. Um, Hey, Sal. What was your original motivation in learning Go? Were you simply curious about its syntax? So I don't know if I already answered that question. So my original motiva- motivation for learning Go. Why was I studying Go in the beginning? I forgot at the moment, but anyway, here's what I can tell you. At the beginning, when I first heard that Google, someone in the Google, Rob Pike and friends, they created Golang. This is like 10 years ago, so it's like 2008 or so. When at that many languages are coming up. So when I first heard that Google created Golang, I think it's crap. I will never learn it. I because so back then I was thinking so we have Java created in 1995. I can understand Java. I can accept we need a new language Java because it has a new virtual machine. The model like supposedly run everywhere by having this virtual machine where everywhere where Java runs, you have to install this virtual machine. And that concept is not new with Java anyway, But however, it was Java is the supposedly it's the first one to make that concept popular. You run a virtual machine, at the end. So Java is kind of supposedly to be a replacement of C++. Now C++ I despise. Okay, it's a wholly complicated crap, piles of shit upon shit, that's C++. Okay, so why people use it? Because they achieve, speed. They grow, they become popular because of the Unix philosophy. Basically you create a virus, get people used to it, then it becomes popular. Industrial has to support it. Then add a little bit features and try to fix it. That's my perspective of the entire C++, and D. That kind of line of the popularity in industry. So I thought Java was, there's a good reason for Java to exist because, it can replace C++, as it's designed, coherently without, not picking back on the history, the baggage of C. So you have Java like a new, okay. But Java is, I don't like. I don't think I don't like Java at all. But anyway, so I think there's a reason for it to get invented. So anyway, 1995. So then you have JavaScript. Anyway, what was I saying? So I was saying, yeah. So when so you have Java, from some microsystems. Then the Microsoft. you know, they get jealous. They had to create C sharp. Like what the fuck? So why do you need C sharp? Why are you doing it? C sharp turns out is some people will criticize, will claim it's just a copy of Java, like a copycat. But according to the inventor, according to some people, they don't think it that way. They think actually. Um, there are arguments about why C sharp is necessary, but in any case, it's necessary in a sense. It's Microsoft's version because when you create a language and everyone wants to use it, you have advantages as the owner of the language. You have quite a lot of advantage. So Microsoft is not gonna, let your some microsystems do stuff. So they create C sharp. Then so and many languages and they are kind of similar, okay, which is in general not a good thing to programmers because as from an engineering perspective, you rather want one system. you know you don't want duplicate, like copy a little variation here just because different corporate interests. So anyway, so that's then you have C sharp, then you have F sharp. Now F sharp is interesting. Now, if you don't know, F sharp is a functional programming language. It's based upon the OCaml, uh, which is based upon Camel, which is based upon ML. Now, the ML stands for meta language, which is what Haskell is based upon. So ML, the meta language, usually called ML, and there are several variations. There's another variation called standard ML. So you have this in the beginning. You have ML, which is meta language. It's designed to do proofs in mathematics. It's a functional language. It is so ML is this is like 1970s, I think. So you have ML, meta language. Then you have some variations. Standard ML. Then you have Camel. Then you have OCaml, which is originally it meant object camel. Okay. Then you have F sharp. Somewhere in between, then you have Haskell. Okay. This bunch of languages are in one family. They are like close, almost the same. So F sharp. So why does Microsoft do F sharp? Of course, it's a good thing in a sense that first of all, Microsoft want their own versions. Microsoft is an industrial corporation, while the Haskell and ML they are typically used in academia in research. So they don't have much exposure to the vast majority of programmers, and they are so it's time, because we have technological progress. So Microsoft decided it's mature now to introduce a functional language as part of the Microsoft core product, and to the vast majority of programmers, industrial programmers, it's kind of very pure functional programming, F sharp, based off OCaml. So Microsoft created F sharp. This is around I think 2005, 2007, 2005, and this is also in 2000s. It's also the time where Haskell became increasingly popular. So anyway, so we have so many languages, right? Yeah. So then around 2008, then Google created Golang. you know and I read, okay, oh, it's from Google, and oh, it's based on Unix philosophy. Well, they didn't say that, but it's based on the guy who fathers, who advocates Unix philosophy. Crap. Okay, it's created by Rob Pike and friends. Rob Pike, the Unix people. I despise. I talked about this many times in my videos. I despise the Unix philosophy. I think it's a cult. It has no content, absolutely. So I heard, okay, Golang, this Unix philosopher, Rob Pike created Golang. So I think, so my opinion is, it's, I'm not, it's the worst. It's probably the worst shit possible. Um, okay, so that was back in 2007 also when it created. But maybe 4 years ago, I think 4 years ago, let's see, Golang. Let's look at my tutorial. I started to write this tutorial in 2016. So I guess around 2016 I started to learn Golang. But why? I don't remember actually why what is the impulse? What's the reason that made me start to learn Golang? I don't remember. I could find out though, because I write blogs. So if I go to my programming blog and go to programming blog archive, then just go through the years after year, starting maybe 2014. I might find my blog where I talked about something about Golang. Um, that's one of the advantage of keeping a diary. That's the purpose of diary. So I don't remember how I got into Golang now, but I do remember when I learned Golang. I read that when you start to learn a language, usually the first task is that there are so many tutorials. You search for Golang tutorial, there are like tens of them, and you have to judge. Use your experience to judge which one is actually good, which one is just crap. Created by these small companies. They just want ad money. They hire people like for $1 an hour or something like that. Cheap to pump out a tutorial for Golang, for JavaScript, for everything, for PHP. So because a lot of people, they want to get into programming. They have no engineering background. They are not interested in math. All they know is that they heard, oh, programmers can make a lot of money. They heard, so they want to get into programming. So when you type any programming tutorial, Golang or whatever language, JavaScript, you'll find a bunch of these websites. They are just like they almost like spam. They just create sites to attract to get ads money, basically. So, and you can always what you can always tell from these this website. Basically, the first thing, the first like litmus test is that is the website pretty. For example, let's say Golang. Okay, let's say Golang tutorial. The way am I still up? Yeah, okay. So, the way you judge, for example, Golang tutorial, okay, this is official. Golang bot, whatever that is, Go tutorial. Yeah, this Go tutorial, this from this tutorial point. Tutorial point is one of the commercial, is one of the low quality, in my opinion, website that creates tutorials for every language. They focus on, you know, their primary audience is people who has no engineering background, not necessarily interested in programming. They focus on the masses. So anyway, so the litmus, one way you can tell which tutorials are good is that if you check their website, if they looks all pretty like this one, like here, oh, logo, pretty logo, nice, graphics, nice logo, nice, social network links. Actually you have to, social networks, they want you to spread. Then the content of the site is probably not that good. Anyway, I digressed a lot, actually, and also look at this fuck. They pop up these. They want you to subscribe or whatever. Is fuck, and they make money. They do actually. They do make a lot of money. This anyway. So anyway, I do remember that, one thing I remember about Golang is that I start to read it. It's very simple. That's the first thing that attract. I find it good. The whole language, like I'm telling you, you can learn, in a day or two. Basically, almost the whole, like, which is not the case with Python. Because each language, Lisp, Python, or Java, they all have a model, or Haskell or Camel. They all kind of have a model behind, like how the how the language works, and this model is almost never explicitly talked about. Instead, as a programmer, when you learn a language, you simply just grok. You just get the feel of it. But this model is never really explicitly talked about, nor documented. For example, if you say Golang versus Python, or versus Ruby, or versus JavaScript, any language, you compare. So what's the difference between them? Nobody, almost basically, only a handful of people can actually explain, because like I can explain what's the difference between Golang, any two language, let's say between Golang or Python. Python is very popular. Well, I can start to explain, or if you ask yourself or any other programmer, they can start to explain. If they have experience, let's say 5 years programming, they can start to, oh, Golang is like this, and you run it, they have this or that functions, different features. Golang's number is that, Python is untyped, Golang is typed. They can explain in this loose manner, okay, this loose manner. But then, for example, then you ask them, so what's the difference between typed and untyped? Because it's actually very complex. The whole thing is entire complex. So very few people actually can explain the real way to explain differences. The real way to explain the differences between languages is to properly explain, is to actually invoke, to describe. Each language, they have a model. Actually, they have kind of a semantic model behind them, and that is like almost never explained or documented. Why? Because it's very difficult. It's extremely difficult to actually explicitly explain or codify, or to write out how the language actually works. It's very difficult. Um, so that is why. Okay, so let me read some comments. I talked about for 20 minutes. Let me read some comments. Then we start to uh, then we start to code Golang. Greetings, Bartholomew. Bartholomew, Bartholomew JS. Bartholomew JavaScript. Okay, so you are a JavaScript coder. Greetings, Deckways. Hi, Xa. You inspire me to make my own do-it-yourself keyboard. Cool. Great. Uh, so let's start coding Golang. Okay, so then I'm going to give you I'm going to tell you what are we going to do. Okay, so I'm going to, if you go to my website homepage, scroll all the way to the bottom, you'll see a sitemap. A sitemap is basically a list of links, all your, basically all the pages on your website. It was popular in 2000s. So anyway, so this is my sitemap. I can randomize the links. I have like 3,000 articles. So sometimes I cannot find the article. Oh, what did I just click? I think I clicked on a ad by mistake. So anyway, sitemap. Okay. So what we want to do is to create a Golang script to generate this content. So every month, for example, every month I'll run a script, and this page will be generated for me instead of manually. But let me show you. Okay, go sorry, sitemap, gen sitemap, go. Okay. Um, oh, bathroom. Okay, the JS does not stand for JavaScript. Okay, sorry about that. Okay. Um, okay, so uh, sitemap. Now let me explain first of all, there's a different meaning. Let me explain what's a sitemap. It's more than that. Okay, so let me show you a sitemap file. So go to my web page, go to what's going on. Okay, so back, go to Xali info sitemap. Okay, sitemap is this file. There is a standard called sitemap, okay, and this is the file. It's basically a XML file. You can see it's a XML file, and each line is a URL essentially, and that is it. So this file is named sitemap.xml. It's a XML file, and this is a standard. There's a spec if you just search for sitemap. And this sitemap is in your home directory of any website. Optional. It's optional. You don't have. It's not necessary, but it's good to have. So, what's the purpose of sitemap? The purpose of sitemap is that search engines, web crawlers, Google, Microsoft, Bing, or any search engine, they can easily find all the content on any domain, on any website, so they can index it. So this is a easy, this is a mechanism how they do that. It's optional. Without sitemap, then the search engine, the web crawler has to like visit every of your website, every page, and they try to extract the page and try to follow those links. Then eventually they get a list of all the URL on your website. So that's very inefficient. So they created this Google. I think Google is part of the original creator who created this sitemap around 2002 or something, to facilitate, to help themselves basically. um, so that's what sitemap is. Okay, so I have a code to generate sitemap in Golang and also in Emac Lisp, and also so I actually, so I have a so this is actually a Emac Lisp code to generate sitemap. And so anyway, I have this Golang script. It's already written, that generates the sitemap, this file. So let's go to my Golang script. So this is my Golang script to generate sitemap. It's 209 lines of code, very short. So let's go to so let's go back to my sitemap. You can see, let's go to the directory. This is the file. So this is the directory web info, and if you scroll down, so you can see this sitemap file. I open it, and this file is 3,600 lines. Okay, now let's delete it. So select the whole thing. Okay, select the whole thing, delete it, save. Okay, now let's go to directory, refresh. You can see it's now 0 bytes. Basically, we deleted it. Let's just delete the whole file. Okay, so it's gone. Delete. I deleted it, and now I'm going to regenerate it by running this Golang script. So I run it. It's running. It will actually generate the sitemap file for all my domains, Xali, info, Xali org, and so on. So you see, it says file saved to here and file saved to, it generates a bunch of sitemap files for each of my domain. So you can see here is the xali.info. Now, if I go back to the directory, refresh, you can see the sitemap file is back. Let's open it. It's there. It's just, the script just generated. So you see, so that is great. This is very useful. Golang creating sitemap. So every time, every month I just run this script, and it generates sitemap. Any comments, questions, comments, and opinions posted? Okay, I'd love to see that. So let's see. Okay, but what are we going to do? You see, it generates a sitemap .xml file, but that file is not this page, because this page is from um, you go to the bottom, you click on sitemap. This page is for users, for people to visit, while the sitemap.xml, that file is for machines, for the web crawlers to crawl. So what I want is to modify my Golang code. This code, let's make a backup. So modify this script so that it actually every time I create a sitemap.xml, it will also update and generate this page. So let's open this page and see what it looks like. So this is a page, Excel code sitemap. Okay, so let's go down. So you can see last update July 8th, and you got this bunch of let's view it locally. Okay, let's view it in my Firefox browser. So this is the sitemap page, 3,000, 4,000 lines. So every month, I have to regenerate this list of links manually. For example, let's delete the whole thing. Okay, show in browser. Now the whole list is gone. So how do I generate it? I go to my sitemap file, Xali info. Okay, Xali info sitemap XML file. I open it. This is a sitemap XML. Copy the whole content, close it, create a new buffer, paste it. Okay, and switch to HTML mod. Okay, now I call the command to remove all the tags. You see these tags? Let's say XML. And why is not? Okay, so it's colored. Okay, so you see all these tags. I want to remove them all. Instead of XML, I want just a list. All these. I want to create a list of links. So I delete. So first thing I do is delete all the tags. I can call this command xar html remove html tags. So all the tags are removed. Then I call another command. Let's just do it. So I call a command xar file linkify. It will take wait. Wait. So I call a command. Wait, what's the command? Oh, okay. So the command is lines to list. So let's call it. I call it. It'll take 3 seconds because there are thousands of them. Oh, well, actually, this. Wait, this is. Oh, it's done. Okay, so you see, it turns the whole thing into a list. Then I copy the whole thing, close this file, and you see I paste it here. I paste it here, and show in browser. So now I got the new list of links. So what I want to do is to do this in Golang, to make it automatic. Okay, that's a lot of talk. So let's start coding. So in Golang, let's start coding. Should we? Are we? So is good so far? So we should start coding Golang. Yeah, let's start coding Golang. So let me take a break and think, regather my thoughts and whatnot. Oh, so Derek Weiss says, how does the list get the titles of the link? Well, that's part of the Emacs command. So let me show you. So that's part of the. Wait, is my Emacs stuck? Okay, no. Okay, so let me show you the. Where is it? Golang index blog. I don't know where that is. So anyway, let's go to my computing blog. Okay, so let me show you the command. So suppose I have a file path. Okay, let's go here. Okay, so go here. Let's say here's a file path of my blog, and I just call a command, and it becomes a link. But however, if I call the HTML lines to list, each line also becomes a link if it is a file path of my website. It's very convenient. Um, and what does so we can look at the code. For example, the code is that. Okay, so it's part of the HTML mod. We go into it. Here's the source code. This so here is a function. And if you search for title, yeah, so here is there is a function that HTML get HTML file title. Basically, it takes a file path and it returns the title of the file. The title of the file is from the the title tag. That's how it so it's just Emacs stuff. Emacs. So Emacs lists. So many technologies to learn. Um, so anyway, that's an advantage of learning Emacs Lisp. You can just create what you need to be done, you know, uh, for yourself. So I'm thinking. So now we need to do. Great. So we need to code Golang, I guess. So are you guys interested in Golang? Because I guess I talked a lot. 40 minutes. Okay. So if we're gonna go to Golang, this is only 200 lines of code. Um, Now, I'm guessing you guys, anyone know Golang? Because in general, people don't. So, yeah, yeah. So, I'm thinking I need to explain. But let me just code it then. Yeah, let me just start to code it. Yeah, and so it's less of a tutorial then. Anyway, so okay, let's just start code. So anyway, so here is a list of path. Each one is a path to a domain, website domain. Okay, so great. So let's do Golang. So each one is a domain name, and let's comment out because we just need to do one. Let's just do xali.info as an example because that's what we need to do. We need to when it generates, so here's what happens. Okay, let's specify more clearly what's going to happen. So this golang script, it will take uh, a file path. The file path is supposed to be the root path of a website. Okay, you'll take a list of file paths. Let's just focus on one. So you take a root of a file path of a website. Okay, then you will go into that directory. It will visit every HTML file, files ending in .html. Then it'll create, basically it'll create a list of all the files. Then it will put all of them into the file named sitemap at the root directory. So that's what it does. That is essence what this little script does. It takes a root file path, it visits every file in that directory, and just generate the report in XML format, and put in, the output is the new file sitemap.xml, and it has some features such as, there are certain paths, certain directory name you want to be excluded. For example, these are documentations, like mirror documentations. I don't want to be part of my website, so this directory will be excluded. Things like that. And also Git directory. It should be excluded. So yeah, so that's what this script does. So yeah, let me go over the general structure. So you declare a package. Every Go language, every Go file must have a package. So if you create a script, the package should be just main. I'm trying to. So that is the basic of Golang. So like if you visit my Golang tutorial, you'll see this is basically the structure of every Golang source code file. Every Golang source code, every one of them have these parts. Package, main. Okay, then import something library, import. You can have a bunch of them. Then function, main. Every Golang must have that. Every Golang file source code. So back to our code. So we have package main. We have import. Let's go back. It's the same thing here. So package main, then import, then you have a main. Let me show you where. Okay, so then you have, let's focus on one place instead of jumping around. So you need package main, then you have a bunch of import library names, then you have, let's go down, then you have main. Okay, here at the bottom, every Go file must have this main function. This is when the program start to run. Okay, so all the things before that, they are just function definitions, like or variable definitions, like kind of global constant function definitions. So in the end, the whole program is just this main. We are running this. So what does it do? So let's look at the main. Okay, so it declares a variable out bytes, which is a sequence, it's basically just an array of bytes. Then for each directory to process, so it's pretty simple. For each directory to process, we set the path to URL, directory path to URL, get matched. So what does it mean? Path to URL. So what does get matched does? Get matched returns the pair from mm whose key is prefix in x if none. What? It's some kind of file name filter. Anyway, so for each directory to process, you get path to URL, then out bytes, then out byte equals to sitemap v's path to URL, then save to path, file path join, then write to file, then just print. So it's so simple, but I have to wrap my brain around it. So this is the whole, this is the thing this program is doing, but what exactly is it doing? So out byte is just a sequence of bytes. So in Golang you create, basically it's like a string. So eventually you are saving out bytes to file. You see, save to variable, save to path. So here is the path to save to. Destination file name, file path v the to process. So anyway, so this is the save to path. Then you write it out bytes. You write the bytes you just generated to the file path. Then you just print. It's done. Okay. So you declare bytes. That's the byte to output. Then you say sitemap v path to URL. So what is this v? So what does sitemap do? So let's look at. So it looks like, so sitemap returns a bunch of bytes. Right. So it's the sitemap generates the whole sitemap file. It returns a bunch of bytes. Then you save these bytes to a file. So that's so sitemap returns the bytes. Essentially, that represents a sitemap file. So how does it work? It takes two functions. So let's look up sitemap function. So sitemap function is this chunk, like 20 lines. So let's look at the declaration. So sitemap takes a directory string, then it takes a another string path to URL. Okay, I understand. So it takes two arguments, two strings, and it returns a byte. Okay, the return value represents the whole XML file. So you can see the first line. You see, it's trying to generate the XML file, the first line. Then it generates the whole XML file basically. But anyway, it takes two arguments, two strings. So what are those strings? So the first string, I should have some documentation. I didn't do documentation. So the x, okay, the directory, the first argument is a directory to descend into. That's the x. Then the second argument, path to URL. Why I'm surprised I didn't write documentation for this path to URL. And now looking at it, I wrote this like 4 months ago. It's not too obvious. It's not very obvious. you know, the ideal program. So this is not good. Well, I mean, in the industry, if you look at the source code, they are much far worse. This is actually clean and short, very clean code. But still, it's not ideal because ideally, you look at, like, if you look at the main, it should be all just obvious. You look at for one, half 10 seconds, you'll understand every function what exactly it's doing. But in my case, it's not. So site, so you look at the main, so it declare out byte. Okay, that's easy to understand. Then it loops through directory to process. So directory to process is very simple. It's a list of you know directories we want to go into. The root directory for each website. Okay, so that's directory to process. Then so you loop through them. When you loop through them, you give them two values. This is the syntax of for loop of a range. So the first variable is underscore. That means it's that basically is an index like 0, 1, 2, 3, 4, and so on. We don't need that, so that's why we use underscore. The second one, v, is a variable. So v is actually each of the value of the list. That's right. V is each of the root path. Okay, so v is just a directory. Okay, so far so good. So v is just a directory. Let's make a backup. Let's modify it. So v replaced by the root. Okay, let's clean up our mess. So v is root. Okay, so root root root. Okay, that should be it. Let's run it again. So let's look at. It should work. It's done. Okay, so now it's still working. So we got so far root. We go through the each root is a directory. Okay. Then what we do is that I learned to make long variable parameter names so that they are documenting. Yes, yeah, I also do that. I that's actually my habit too, because my variable and function names tends to be long, like 30 characters. Um, there's an interesting thing when I try to code Golang. Golang is in the community in a style, in a system programming. How they call it? The it's basically C and C++ community. And this community, their programming style is rather different from scripting community. Bash, Python, Perl, JavaScript, these scripting languages, there's a bit different. So in C kind of languages, they tends to be short, very short characters. So what I was saying, so when I started to code Golang, it's interesting because it's new, it's fresh. It changes your habit change. My habit changed a little bit to follow the Golang conventions. They don't want elaborate 30 character names. They want typically short. Anyways. So root is a directory. So the first thing we want to do is to uh, uh, yeah, I prefer long name. It's an interesting question because I don't, you know, I think there is no right answer because it's like people say it just depends on some kind of balance depending on the context, depending on the function, what situation, what meaning of the variable at the time. It's kind of depends on that because on one hand you could go overboard with long names. Like when you have lots of long names, then it becomes less readable. On the other hand, if you name everything, one or two characters, that's obviously bad, you know. So, so another interesting thing is that we actually, as a programming practice convention, we don't have a solid science on this issue. ideally we could have, let's say there's a solid subject, like scientific based study. Like maybe we have eventually we might have maybe 10 or 20 years later, but we right now we don't have like solid science about like exact formula or algorithm that says when exactly is a variable named, what how many characters it should be. That's too much to hope for right now. Like right now, all the programming, this is part of the problem in programming, debates or among different languages, like, oh, which one is better, or your language is better, or mine is better. We have tons of these debates, arguments, sometimes silly, and once in a while, every year we have PhD thesis. They try to study. For example, there are several PhD study, or research about the naming of variables, like whether snake case is better or camel case is better, like which one is actually more readable, which one takes more training, which one actually, there are several studies, but it turns out it's not conclusive, like they don't have a um, good answer to that. Greetings, Danielle. Greetings. So, anyway, we digressed. Anyway, let's back to this. I don't think I'm doing a good job of doing this Golang coding. We just keep digressing. But anyway, so get matched. What does get matched do? Get matched takes two arguments. So the first one is a directory, root directory of a website path, and the second argument is the path to URL. That is confusing. What is the path to URL? Um, oh, okay, I see. Oh, okay. So the path to URL is a hash table. In Golang, you don't have a hash table. Well, in Golang, hash table is actually called map data structure. They have a data structure called map. Okay, so the keys are string, and the value is also a string. That's how you declare it in Golang. It's a hash table, or in Python, it's called a dictionary. So the path to URL is a dictionary. So keys are the root, the path of a website, of a domain. The value is its domain name, basically the URL. So we need this obviously. So you need, the keys are the directory path. The value is the actual domain name. So you need this. So this hash table, this dictionary is called the path to URL. Oh, okay. So this get matched function takes two arguments, a root directory and a dictionary. So let's see, what does it do? So get matched return a pair from. Okay, so this is so bad documentation. Like get match return the pair from returns the pair from oh, okay, I see what it is. So basically, given a root path of a website, you want to get the domain name. So how we do that is via this get matched function. You know, okay, so I see what it's doing. So so get matched actually take a dictionary, take this structure to get the result. So basically, given a file path that's a root path of a website, you want to get the actual domain name for that. So that's what this get matched does. So this path to URL is actually a list of two items. The first item is the file path to a website domain. The second item is the actual URL for that. Okay, path to URL. That's also badly named. It's badly named. It's not really path to URL. It's actually just a pair of yeah. It's not good name because path to when you think of path to your URL, you think of it as a function. It's not a function. It's just a it just in Golang it's an array. It's just it's a slice. It's just a array of two items. Anyway, so now I understand path to URL. Then we get to the sitemap. Okay, now it's easy to understand. Sitemap takes a router and takes a so this is also badly structured. So sitemap takes two arguments, a root directory, then the second argument kind of repeats the first argument. The second argument actually should just be a domain name string that corresponds to this router. But instead, the second argument is a list with two elements. The first element is a router. The second element is a domain name. Anyway, so that's what sitemap is. Okay, so actually, I think I'm going to just skip the coding today because it's already 1 hour. Unless you guys want to see it, because we already talked for 1 hour. Okay. Avoid that words. Okay. so clean code I have heard is the more what the fuck you hear when someone reading in your code, the unclear your code actually is. Yeah. The more you hear what the fuck, the less clean code it is. Yeah, that makes sense. So anyway, I digressed a lot. Yeah, so it's actually so now actually we understand what this sitemap is doing. Sitemap is the heart of the whole thing, basically. So the sitemap, all it does is that it takes a root path string, then it takes basically it needs a domain name for that string. Then it generates a sitemap. And the output is a byte string is a byte slice of bytes, a sequence of bytes. Then we look into the code. You can see it's so what is it doing? So it uses append to append the output. So first of all, it declare the output. Output is a sequence of bytes. And the first sequence, the first bunch is basically this line in XML for the sitemap. Then it just call append. So append output, then you append the second line, and then it start to walk. Yeah, so it then use okay, wait. You define a function that walks a directory. Yeah, so we need to go into a directory. We need to find all HTML files. Then transform from a file path into a URL, with the help of the domain name. So that is this function, this p walker function. So then we actually call the walker function, uh, with the file root. Uh, right, we call the walk function. We call the p-walker function. Wait, what? Wait, let's go back. So we call the walker function. So what does the walker function do? Basically, the walker function just append stuff to the output variable. Just basically for each file it encounters in a directory, for each file, it just append a line to the output. Then it just does that. So it works by side effect. It's not functional programming. In this case, it's kind of necessary in that way because Golang is not Haskell. So you need to, so for each file you just need to append a line to the output XML. So after that, so we call the file path walk, then call the p-walker function. That basically traverse the directory. Then we check the error. Golang is known for error checking, which is very annoying. Then it's done. You just append the last line for the XML file URL set. Then return the output. The output is a sequence of bytes. Yeah, that all makes sense. So this is the sitemap function. So here we call the sitemap function. It returns the sequence of bytes. We assign it to out bytes, and we just save to the file. So that's how it does. Pretty bad. I mean, the code is not bad, but it's not optimal because it's not optimal in this. It's actually very efficient. I wrote this code. I know it's very extremely efficient. It cannot be possibly more efficient. In other words, there is no inefficiencies. But however, it can be refactored because we see, for example, the get matched is a bad name. It's not. And the sitemap is also, it should be maybe called generate sitemap is a better name instead of just sitemap. Also, the argument, it should be a domain name as second argument. Like when you code to yourself, everything is obvious. Especially like now I'm familiar with this code. Now I can start to do what we originally need to do, which is also okay. So what we need to do now is so after all this is done, okay, so right here we need to open this file. Open this file. Let me write it down. So open this file. Actually, there's a file path, a local file path. So we need to open this file. Okay. This file, which corresponds to this URL. So we need to open this file. Delete. Find the let's delete the list of links. Generate a new list of links based on our XML file. Based on our XML, based on the XML we already generated, because you see we already generated a XML file where each line is basically the file, the domain name, the URL. So you can see. So right now we can see it doesn't work. We cannot just uh, do it, because we need to, because when the sitemap, the way sitemap function works is that it simply traverse into a directory. For each file it encounters, it just add that line into the output, which is a byte sequence, just into a file, into the byte sequence output. It does not it does not actually generate a structure of all the files, like a list of files. It does not generate a list of files. Rather, it directly dump, the file path to the XML file. Therefore, but now we actually need, list of files. So we run into a problem because we don't have a structure that's a list of files. So we need to either modify, the sitemap function so that when, so instead of just directly output, append to the output, instead of that, we actually generate the list of files. Then we can do, we can convert the whole list into a output XML file. So that way we have a list of files. Then now we need to generate the list of files over here on this page. We can use that structure. So that's what we need to do. So then insert into the page and save it. Yeah, so that's what we need to do. God. So at this point, should I? I already talked for an hour, kind of long. Should I start to code it? We could. Yeah, we could actually start to code now. Now we spend the time to look into. Actually, this is actually a real live coding. Yeah, it does make sense. Real live coding is like that. It takes time to read the code to understand what, the code you haven't touched for a few months. Now I do understand how it works. Now I know. Now we have a clear steps, of what we need to do, a spec, and we know how to do that. So what we need to do is we go to the sitemap function. We go to this function, and we need to, first of all, the first thing is to modify the code so that it generate a list of files instead of, direct output. Yeah, we can do that. Yeah, so 1 hour and 10. So I'm thinking, let's do 10 more minutes. Okay, 10 more minutes. Doesn't matter we finish it or not. Then that'll be it for today, because this is getting long, and a lot of talking, and I'm tired too. Oh shit! I don't have my power drinks. Wait, do I have? You see, this is my. Let me show you. God. Let's see if I can. You see my energy drinks. This is, and I need a new one. So let me get. Pineapple flavored band. This is a cheap brand of Red Bull. Essentially, that's what it is. A cheap brand of Red Bull. And it's $2 a pop. I've been drinking these kind of energy drinks for like 5 years, 6 years. Oh my god, it's actually no good. It's addictive. I used to drink sugared ones, and destruction. That's very destructive to your body. So I never drink pop drinks with sugar, like Coke, Pepsi. I never in my life. Well, when I was young, maybe once when I was younger, like 13 or below, I drink that. But as an adult, since 15, I never drink Pepsi. Any sort of that sugar drink. Never, but however, 5 years ago, I started to drink these energy drink, sugared ones. I did that for like 4 years, 3 years or so, and that's very bad. It does bad things to your body. In your body, in your thighs, especially girls, women. This is of great concern to females. On their thighs, they have what's called cellulose. Like you can, it doesn't look good. That's kind of cellulose. When you drink sugar drink, I start to have that, sugar drink. So sugar is the thing you don't want. So now I don't drink any sugared energy drink anymore. Okay, so yeah, maybe I should stop now. I've been random talking a lot. So actually, that's good. That's what Saw Talk Show is. So thank you guys for watching. Thank you, Dick West. So Dick West. So what? What? So so you are also a programmer. Where are you from? And like in USA or in what country? That's always interesting. And one question. Okay. So what question? Hey, Daniel. Yeah. Oh yeah. You were here before. So what's up, Daniel? Rust versus C. Actually I can talk about that right now because actually I don't have much to talk about that. Okay, because first of all, I don't know C at all. Okay, people may get an impression I know C. Actually, I don't know C. I do not know C. I do not know C plus plus. Uh, I despise them. I hate them. Just uh, I don't know C actually. So like meaning that I've never coded more than 10 lines of C. All I've ever did is maybe hello world, a factorial when I was learning it. I'm not, I never actually spent much time learning it. So I don't know C. I don't know C plus plus. And what? So in my programming experience, mostly I do web programming and scientific programming. Uh, that's mostly server, web server front end or back end, and scientific programming, mostly mathematics, geometry visualization in Mathematica mostly, and that was mostly in 1990s and 2000s. And I still do today, geometric, geometry, visualization of math, fantastic. So and I have a thing about programming languages, so I learned. Oh, and also, most of my experience, I'm a functional programmer. I mentioned before, especially with Mathematica, and I never used OOP technology. I never in my code. When you work in a company, maybe it's different because you have to follow, you know, uh, programs that already exist, OOP style or whatever. But in my own code, I never use OOP in JavaScript, not in JavaScript, not in Python, not in Golang. Golang has interface as the interface mechanism in Golang is the OOP mechanism for Golang. Golang doesn't have object like Java or Python. Golang doesn't have that, but rather it has interface and struct. That's how you have the whole OOP paradigm. So anyway, so I don't use OOP at all in any language. Because I don't like it. I don't think it's good. And I love programming languages. So most of my experience and my perspective, I came from a math background. So first of all, I'm a mathematician first. if that, math is very difficult. You could say I'm an amateur mathematician. So math first, then programming. So my perspective is more math oriented and high level language oriented. So I don't actually have much experience with system programming, like C, and no experience with C or C++. I don't know Linux kernel. I don't know about drivers, how to write a driver. Those kind of thing. I don't know. I don't have much experience. I don't have any experience. I never coded assembly language. But I study them. I especially in the past few years, I try to study some of them. So my opinion about about Rust versus C. I don't have much opinion, except that they are low-level languages. I don't like them. Okay, don't use them. And C, I don't like them because not no, okay. Here's what's important, and maybe it's fun to say. Okay, it's what talk show is about, being dramatic. Okay, I don't like them not because they are low level languages. Okay, obviously low level languages such as C, Rust, assembly, they are incredible. They are fundamental. They are absolutely essential. They are the underpinning of all programming languages. You need them. Okay, assembly, of course, obviously, machine language, assembly, C, you need them absolutely. Personally, I don't like them because I tend to be the math oriented high level. I prefer high level languages, but of course the low level languages are critical and important. But that's not the reason I don't like C or Rust. The reason I don't like not Rust, okay, but C and C++ is because the way they are designed. I mean, they are low level language, okay, that's fine. But the way they are designed, in many ways, in my opinion, is the worst crap. It's from the Unix philosophy, fuckheads, okay. The the Unix philosophy. They are the virus. They C and Unix is what created, in my opinion. This is a dramatic saying. Okay, they are the father of everything that's wrong about computing industry. So every time you run into a problem, bad design, no documentation, I blame this on C and Unix. Okay, and okay. So what about Rust? So as far as language is concerned, the newer language are always better than than the decade before that. So every decade you have new languages. In general, they are just better. Period. Okay. So Rust and C, I would think Rust is good. Um, so I would in my idea, so first of all, like I said before, technically, I don't know anything about them. So take my opinion is just opinion. I don't like Rust either because it's a fad, it's a fashion, because especially in industrial programming, most programmers, especially these elite hacker types, they tell you what to do every day. They tell you, how you should format your code. These type of people on Hacker News, the, they tend to all are big fans of Rust. Because why? Because Rust allows you to control memory and so on, and compilers and those complicated stuff. They tend to all like love it. Like for example, on social media, on Twitter, you will see a lot of people. Oh, Rust. Oh yeah, we this is so cool. Rust. This that. But they seems to not like Golang because Golang is just simpler and higher, kind of high level. You see more like cool, more this fad on Rust. You see this phenomenon. So that's what I'm saying. So that's why I don't like them. So technically, I cannot comment on Rust. Well, Rust was, technically, I don't know technical details about them, but I can say for sure Rust is better than C. So if you want to learn Rust versus C, not for a job, but just for your own. I would choose Rust for sure, because in my experience, the conclusion is that the later language, like after 10 years, is always better. That's just the way things are, because there are tremendous changes in industry, in CPU. Later on are always better. Like after a period of 10 years, not less. Uh, and C, I don't like C. So, but then there's the situation where Rust, there's a fad phenomenon with Rust, and that I don't like. So my comment about them is just mostly a kind of a social ones, yeah, about Rust and C. So that's it. Um, that's it for today. So Danielle says, uh, so Bartholomew says, "Well, people praise C for speed so much. Do you think speed is important nowadays as much as security has become? C. Speed. Yeah. Why C and all these garbages thrive, because one thing, speed." Like that's worst fuck. That's why they become this virus that spread. They'll say, oh, because we are fast, I'm faster than you. C and Unix is such that they are the worst engineering, the worst architecture, the no brainer, no design, no sloppy, unthinking, not extensible, like, because there's no design went into it. All they care is one thing, like every dummy we all know about this thing: speed. They run very fast. So that's one of the fundamental reasons C thrives. The Unix virus and C. You have this garbage. It just thrives. They anyway. That's kind of a rant. That's my Okay. Danielle says the most important thing about Unix is that hordes of people ends up uh, running away, screaming from their proprietary systems. So to uh, to flock to Unix. The most important thing about Unix is that hordes of people ended up running away, screaming from their. No, that's not. Well, that. Then Danielle says so many of those coming a world of closed or proprietary operating systems, walled gardens. No, that's I know what you are saying. You are saying basically you are saying, so like Microsoft and they. No, that's what people would call apocryphal history. That's what Unix lovers love to say. They believe that. They think, oh, because Unix is a free system. That's not true. Unix was proprietary, very evil, the most evil fuck proprietary system from AT&T. Okay, that's a history of Unix. It just happens to be, Linux came from that, happens to be GPL licensed, and FreeBSD, it was, came is another offshoot of the Unix system. This is Xadi Rant. So, for example, Xadi Unix pestilence. I'm gonna show you some historical images how Unix was the hated commercial, the huge, like what you would regard as, Apple, Microsoft. A lot of people, these people, Unix fans. So I'm gonna show you some artifact. These are called artifact. You see this T-shirt? That's FreeBSD. Okay, this is back then DOS when it was running FreeBSD. Okay, look at this one. You got this BSD demon. This mascot called his name is Beastie. I think was it Beastie or Chuck? There's some confusion there. Anyway, this BSD mascot logo. Okay, now he's poking the AT&T logo, Death Star. Now this was used to be AT&T's logo. AT and T logo. Let's see what's their current logo. I think it's a variation. You see, there it is. Yeah, this is a modern one. The old logo is a bit different. It's got more stripes. So anyway, that's AT&T. Okay, they used to, remember, they used to, in like, this is before my time, in the 70s or something. They used to be this powerful monopoly. What's so-called monopoly. They got broken up by the government into different companies. But anyway, AT&T owns Unix. Unix was proprietary by AT&T. So you see these comics on a T-shirt, that's making fun of it. The Free the Berkeley 4.4. People forgot history. By the way, I'm not saying you are wrong. Okay, so I mean, definitely the Unix. I mean, definitely there's some connotation. I don't know where it originates. I mean, the point is that definitely there is certain association of free software or open source with Unix. I mean, I don't know when it began. I think it's starting with FreeBSD. Okay, but it definitely is not the history of Unix originally. You see, remember the name GNU. The Free Software Foundation GNU project, which is a project to create a free operating system. GNU, what it stands for? It stands for GNU is not Unix. Now look at that cute demon. This. By the way, this is a Linux conference back in year 2000. I went to. This is not actually. This is not my photo. But anyway, so GNU is not Unix. Remember that name? What does it stand for? GNU is not Unix. Why is that? So what do we need? Why do these GNU people create a name that's GNU is not Unix? That part of the reason it's a snub against Unix, the proprietary system. So we are not Unix. Fuck you. Go fuck yourself. GNU is not Unix. That's my perspective. That's my interpretation of it. Okay, I've run into many Unix fans. Of course, they don't have that interpretation. They would like to. They prefer to think, oh, it's just a fun. It's just a fun way to promote Unix and GNU. This fuck. Uh, So anyway, so that's it for today. Thank you guys for watching. That's a long rant. It looks like almost every video ends up me ranting against either open source or Unix philosophy or Free Software Foundation. Anyway, that's it for today. Thank you guys for watching. Bye.